We are here to define the specific architectural problems that supply chain management is engineered to solve. The physical movement of a container ship across an ocean is the final, visible manifestation of a complex, invisible system. Behind the logistics of moving boxes lies the challenge of managing systemic complexity. Within a formal framework, SCM is the practice of delivering the right value to customers at the right time and at the right cost, regardless of uncertainty. Friction enters this process because modern value creation relies on the interdependence of multiple, unaligned organizations. Supply chain management acts as the discipline that prevents these multi-firm networks from collapsing under the weight of that friction. It is a branch of systems engineering and alignment rather than a simple matter of transportation. The first axiom of operations involves a constant tension. Supply must continuously meet demand. This diagram illustrates the structural mismatch. On the left, consumer demand is volatile, fragmented, and inherently uncertain. On the right, supply capacity is rigid and constrained. Production lines and shipping lanes are slow to adapt. When you attempt to match a fluid variable against a rigid constraint, forecast errors become a mathematical certainty. These errors amplify as they move up the chain. A minor shift in retail sales creates a larger shock for the distributor and a total disruption for the manufacturer, the bullwhip effect. Without an overarching management strategy, the system oscillates between two failures: holding massive excess inventory or suffering critical stockouts. SCM intervenes to resolve these timing and quantity mismatches through strategic forecasting and capacity planning. It reconciles the chaos of human consumption with the rigid physics of production. The second challenge is the fragmentation of value creation across internal functional silos. This leads to local optimization, where each department pursues its own metrics without regard for system-wide impact. For instance, procurement might buy raw materials in massive bulk to lower unit costs and meet department savings goals. While procurement records a win, operations is burdened with massive holding costs for excess inventory. The net result is a systemic loss. This conflict repeats across company boundaries, as the incentives of a buyer firm often work directly against the incentives of a supplier firm. Information asymmetry acts as the catalyst for these conflicts, as no single entity sees the entire value chain. SCM breaks these silos by aligning incentives and information across the entire network. Without this framework, a cost saving in one functional area mathematically guarantees a larger systemic loss elsewhere. The third challenge involves operational trade-offs. No organization can maximize all performance dimensions at once. This efficient frontier demonstrates the reality of the choice. To drive down costs on the x-axis, you must accept a penalty in service levels or responsiveness on the y-axis. SCM addresses this by making deliberate choices about where to place buffers within the network. These buffers take four forms: inventory, capacity, time, or information. A system must utilize at least one to handle uncertainty. Poorly managed trade-offs lead directly to flow inefficiency. Physically, this looks like queues, bottlenecks, and stagnant material piling up in warehouses. Physical movement represents only half of the system. It requires a parallel, synchronized flow of information to dictate every step of the journey. When material and information flows are out of sync, the result is a slow cash-to-cash cycle, trapping working capital that could be used elsewhere. Practitioners re-engineer these flows to bypass structural bottlenecks and compress lead times. Proactive strategy is defined by the ability to design these trade-offs and engineer smooth, predictable flow. The fifth challenge is the reality of exogenous risk. External shocks can break even the most efficient network in an instant. Networks face demand shocks, geopolitical instability, natural disasters, and supplier failures. To mitigate this, SCM employs risk pooling, supplier diversification, and a calculated balance between network resilience and total efficiency. This leads to the overarching challenge, the strategy-execution disconnect. Executive boards often possess clear strategic goals, but their underlying operations are mechanically incapable of executing them. A company might promise high market responsiveness, while their actual operations team is locked into rigid networks with 3-month lead times. Without a translation mechanism, corporate strategy remains a theoretical exercise confined to slides. SCM acts as that translation layer. It takes abstract goals from the top and converts them into hard network design, planning horizons, and concrete inventory policies at the base. It is the mandatory bridge ensuring a company's external promises are physically supported by its internal operational physics. Viewed together, these 6 challenges define the operational environment of the modern firm. The discipline requires the systematic alignment of incentives and the management of unavoidable trade-offs. Success is found by designing resilient flows of physical material, synchronized digital information, and liquid cash that can withstand inevitable uncertainty. Managing this end-to-end complexity more effectively than a competitor is the primary source of operational advantage. In the modern economy, competition is no longer between individual companies, it is between the supply chains they command.